Alright, so now we're going to have a look at another question. This comes from an old university Calc 1 paper. Calc 1. This comes from 2014. So this is the first long answer question, so to speak. So this question you actually have to do a whole bunch of calculation. You're marked on working and answer. All of the previous questions are multiple choice. You just get the mark if you select the right answer. The working is irrelevant. This marks for working and mark for answer. So this is question 33 in the paper. Now this is a pretty easy question because it is 2 plus 2i to the power of 5. You can just do this with a whole heap of bracket expansions. So you can write 5 lots of this, expand all of this, simplify it. It's messy, but it's a pretty straightforward process. So the markers have made this question very nice. They've made it very forgiving if you can't remember specifically how to do de Moivre's theorem. In fact, this can be done through bracket expansions or it can be done through de Moivre's theorem. I'm going to do it with de Moivre's theorem because that's the better way to do this question. If you have a lecturer or tutor or professor who is not so nice, this kind of question, still worth 3 marks, would be find 2 plus 2i all to the power of 153 or something like that, right? It would be some massively high power where you could not use bracket expansion within the context of the exam, because the exams are quite fast, right? If you have a Calc 1 or Calc 2 exam, it can be anywhere from 2 to 4 hours, depending on your university. It could be faster if it's midterm exams or something like that, so a smaller time window. But you have, a couple of minutes to do a question like this. So you have maybe 5 minutes realistically to do this question. You can't expand brackets, 153 brackets in that time window. So you have to have another method. So we're going to be using de Moivre's theorem. De Moivre's theorem is quite nice, so it's going to work pretty well. If we know that a complex number z has the polar coordinate form r times cosine theta plus I sine theta, then it follows that z to the n is equal to r to the n times cosine of n theta plus I sine n theta. So this is de Moivre's theorem down here, and we're going to be using this in order to find the z power. Now we have been given a Cartesian form of this complex number, 2 plus 2i. We need to convert this to a polar form, which will be r times cosine theta plus I sine theta, sometimes called cis form. We're not going to use the phrase cis, we're just going to say cos I sine, because that's easier. So if we draw this vector in the Argand plane, this is 2, this is 2i, let's call this y, let's call this x, and we're going to say this is Argand. It's here, points this way. So its Cartesian coordinates are 2, 2i. Its polar coordinates are going to be r, which is its length. It's going to be the length of the vector, and it's going to be theta, which is going to be the angle from the positive x-axis. So this will be angle from pos x-axis. So r length, that'll be this. Theta, that'll be this. So we just need to find these two, plug it into this form up here, and then we can start using de Moivre's theorem to find the fifth power. So this is just a right triangle. The base is 2, the height is 2. So r is going to be the square root of the sum of squares. That'll be the square root of 8, which will be 2 root 2. The angle, because the slope is 1, it goes across by 2, up by 2, the angle has to be 45 degrees. So theta has to be pi on 4. So we've got r is 2 root 2, theta is pi on 4. This means the complex number denominated in terms of denominated in polar form is 2 root 2 times cosine pi on 4 plus I sine pi on 4. Now we need to find the fifth power. Well, we can just use de Moivre's theorem for this. Z to the 5 has to be 2 root 2 to the 5 times cosine of 5 pi on 4 plus I sine 5 pi on 4. And this is actually going to be our answer. We will want to simplify it back down to a Cartesian vector though. So this question, you could leave it like this. It's not a particularly good idea to leave it like this. Some markers might say, well, yep, that's a form of the answer. It's not very simplified, so we're going to simplify it at least a little bit. So we need to do 2 root 2 to the power of 5. So you can do this manually. This is something that you can use your calculator to do. This is the same as the square root of 8. So we can say square root of 8 all to the power of 5. And if, well, we can do 2 to the power of 5, which will give us 32. And then we can have root 2 to the power of 5. So that will be root 2 times root 2 is 2. Root 2 times root 2 is 2 times root 2. That will be 4 root 2. So we will get 32 times 4 is 128. This will be 128 root 2. So this will be equal to 128 root 2 times cosine 5 pi on 4 plus I sine 5 pi on 4. Now this is a polar coordinate vector that has length 128 root 2 and it has theta 5 pi on 4. So if we draw this, this is 0, this is pi on 2, this is pi, this is 3 pi on 2. So 5 pi on 4 is down this way. Its length is 128 root 2. And its angle is 5 pi on 4, that's this angle here. Because this is pi, 5 pi on 4 means we're moving pi on 4 counterclockwise from pi. But pi on 4 is of course 45 degrees. So when we're finding the Cartesian coordinates, we'll call this one alpha, we'll call this one beta, they're actually the same. This is it's an isosceles triangle. Right? These two side lengths are the same. So we just need to find one of them, and then the coordinates of the power will be one of them plus I times that same number. So let's use some Pythagoras theorem. We have alpha squared plus beta squared is equal to 128 root 2 squared. Alpha squared and beta squared are the same though, so this means alpha squared plus alpha squared is equal to 128 times root 2 squared. So this is 2 alpha squared is equal to 128 squared times 2. We can divide both sides by 2, take the square root. This tells us that alpha should be 128. So this means this distance is 128. So this means the x coordinate is minus 128. This distance will also be 128. This means the y coordinate will be minus I 128. So therefore 2 plus 2i to the 5 will be equal to the vector minus, the complex number, minus 128 minus 128i, which we could write as minus 128 times 1 plus I. So this is an acceptable answer to this question. And we know that minus 128 times 1 plus I is in fact the answer. This can be done numerically. You can get a computer to check this. You could have done the bracket expansion. So this is definitely the answer. The relevance of this question is not so much as to whether you can get the answer. Getting the answer is not really the important part, because you often start these questions knowing the answer already. Sometimes they'll say the 58th power of this complex number is this. Why? The relevance of this question is showing that you know how to calculate it one way or another. This one was very nice. It's a nice exam question because the power was really low. But you could get a really high power as well, 100, 200, 1,000, 10,000, or some weird number, 376, 57, 1,824. They might ask you that, right? You do often see those kinds of questions in the notes as well.